only few problems are remaining in this vector algebra. That is also a problem based on scalar triple product. We'll see those problems. Okay, that completes this chapter. Now, what is meant by scalar triple product? It is represented by A vector dot B vector cross C vector, right? So this is a scalar triple product. To find this, what you have to do? You have to write the coefficient of A1, A2, A3, right? B1, B2, B3, C1, C2, C3. Then you need to find the determinant of this matrix. I mean this determinant you have to find. It will gives you a scalar triple product. This is also can be represented by A vector, B vector, C vector. So this is also called a box product. Remember that scalar triple product or box product. Now we will see this one. See, find A vector dot B vector cross C vector. So we need to find the scalar triple product. What it will be? Simple, it is A vector, B vector, C vector is equal to determinant of, write the coefficients 2, 1, 3, coefficient of B vector or components 1, 2, 1, components of C vector is 3, 1, 2. Now we need to find the determinant of this matrix, so it will give you a scalar triple product. Okay, complete this. Now we'll see the second question. Find the determinant of this matrix. Now show that the vectors A vector, B vector and C vector are coplanar. What you have to prove? When the vectors will be coplanar, three vectors, if their scalar triple product is equal to 0. I mean if it is A vector dot B vector cross C vector is equal to 0, then we can say that those vectors are coplanar. Okay, this type of problems are important for 3 marks. Now see what I have to prove. Determinant of the components of this matrix should be equal to 0. If it is equal to 0, then we can say that these three vectors are coplanar. Coplanar is nothing but they lies on a same plane or they will be parallel. See, A vector dot B vector cross C vector. Find the determinant. This is 1, minus 2 and 3. Here it is 2, 3, minus 4. It will be 1, minus 3 and 5. Now check whether the determinant of this matrix is equal to 0. If it is, you have to get this as 0. If it is equal to 0, then we can say that these three vectors are coplanar. Okay, complete this. I mean find the determinant and verify this is equal to 0. See this one. Find lambda. Okay, if the vectors A vector, B vector and C vector are given, those are coplanar. It is given that those are coplanar. That means scalar triple product of those will be equal to 0, right? So this is also important one. Given, what is given? A vector, B vector, C vector are coplanar. Since this is coplanar, what we can write? Scalar triple product, it will be A vector, B vector, C vector will be equal to 0. So we'll write that what it will be. This is 1, 3, 1, it is 2, minus 1, minus 1. Here it will be lambda, 7 and 3. So this is equal to 0. Now we need to expand this. Let us expand. So delete first row and first column. So this is now minus 3 plus 7, right? Minus 3 into, delete this and this. So 3 into 2 will be 6, minus into minus will be plus lambda plus 1 into, delete this, so 7 into 2 is 14, minus into minus will be plus lambda is equal to 0. Simple it is. So this is minus 3 plus 7 will be 4, minus this will be 18, right? Minus 3 lambda, see minus 18 minus 3 lambda plus 14 plus lambda is equal to 0. So it is now 4, this will minus 14 plus 14 will be 0. So 0 minus 3 lambda plus 2, this will be minus 2 lambda is equal to 0. So the value of lambda is equal to 0. So here, so the value of lambda is equal to 0. This is one of the important result. This is useful to solve the objectives also. Prove that A vector plus B vector, B vector plus C vector, C vector plus A vector is equal to box product of A vector, B vector, C vector. That means this is a scalar triple product is given. So this can be written as, see here, A vector plus B vector, right, dot product with B vector plus C multiply this. So this is now A vector plus B vector dot, I'll multiply here B vector cross C vector, B vector cross C vector plus B vector cross A vector, B vector cross A vector. Next will be plus C vector cross C vector. It will be equal to 0, right? Remaining with C vector cross A vector. C vector cross A vector. Now again we have to find the dot product with this one. So it will be C A vector dot, first we will multiply with A vector dot B vector cross C vector plus A vector dot B vector cross A vector plus A vector dot C vector cross A vector plus what is remaining? We have to multiply by, we have to find the dot product with B vector. So it will be B vector dot B vector cross C vector plus B vector dot B vector cross A vector, plus B vector dot C vector cross A vector. Simple it is, okay. Just first you have to find the cross product of this, then you have to find the dot product with A, then you have to find the dot product with this B, okay. So now this is as it is. What I can write this as, this is a scalar triple product. I can write as A vector, B vector, C vector. Now what about this? See here A vector and A vector will be there. So this is equal to 0, right? And here A and A, again this is equal to 0 because two rows will be same. If it is any two rows are same, then the determinant will be equal to 0. So here this is also equal to 0, right? And this is 0. What is remaining? B vector dot C vector A vector. Now is it equal to this one? See, if you find the cyclic order, so this will be now C vector C vector and A vector cross B vector, right? If you find again cyclic order, this will be A vector dot B vector cross C vector. Both will be same, right? So this is A vector dot B vector cross C vector, and there it is A vector dot B vector cross C vector. So I can write plus A vector B vector C vector. So this is equal to 2 A vector B vector C vector. Actually this is not important, okay. Just remember this, result. This is also another important result. A vector B vector C vector plus D vector can be written as A vector B vector C vector plus A vector B vector D vector. Okay, we'll consider this. First A vector B vector C vector plus D vector. So the dot product, scalar triple product can be written as A vector dot B vector cross C vector plus D vector, right? We'll find the cross product of this. So it will be A vector dot B vector cross C vector plus B vector cross D vector. Now if you find the dot product of this will be A vector dot B vector cross C vector plus A vector, again A vector dot B vector cross D vector. Now what is this? A vector dot B vector cross C vector can be written as A vector B vector C vector plus this will be A vector B vector D vector. Proved, right? Just remember the result, okay. Actually this completes the chapter. Simple chapter, don't leave anything, okay. Study each and everything. Easily you can score 11 marks in this chapter, okay.